Welcome to Brain Vision.
So for this problem, we're going to be evaluating a surface integral. And to do so, we're going to use the following formula. So it'll be the double integral of f of g of yz, y of z, times the square root of the partial derivative of x, or the partial derivative of g with respect to y, squared plus the partial derivative of g, or the partial derivative of x with respect to z, squared plus 1 dA. And with that, given what we have, we know that this is going to be 5 minus y times z. And then evaluating this, because we know that x equals 5 minus y, this is just going to be 0, and this is going to just be a 1. So we'll end up getting the square root of 2, which we can bring out in front. Then we want to change this to polar coordinates, because we know that the region is inside. We know that D, the region, is a disk. So we know the radius is between 0 and 3. And since it's a disk, we'll have from 0 to pi, 0 to 3. And this will be, instead of 5 minus y, it'll be 5 minus r cosine theta. And then instead of z, we'll have r sine theta. And then this will become r dr d theta. Then with this in mind, we need to combine some of the r's. So we'll end up getting a 5r sine theta minus r squared sine theta cosine theta. And in this case, it'll actually be r cubed, and this one will be r squared. Then we can evaluate this integral. And once we evaluate it, we can separate these individually, or we can do them together. Ultimately, though, we'll be able to determine, since this is going to be 2 pi, and since 0 to 2 pi of the sine of theta d theta is just 0, and from 0 to 2 pi, the cosine of theta sine theta d theta is 0, we see that all of these integrals will end up giving us 0. So that will be the final answer that we have.